Hey everyone, it's Mr. Wolfe here, and in this video I'm going to be going over or introducing the scientific practice of planning an investigation. So any good scientific investigation starts with a question. This is one of my favorite quotes about science. It was something that I heard in college. I forget the name of the scientist who said it, but I remember the quote. And it was, so much of science is not finding the answers, but asking the right questions. It always starts with a question. So in general, we're going to always have like a template in terms of how we might go about asking these questions. And simply it's, how does the independent variable affect the dependent variable? So how does the independent variable affect the dependent variable? In an example experiment, let's just say we're asking the question, how do distractions affect reaction time? Distractions would be our independent variable, and reaction time would be our dependent variable. So I know you've heard those terms before, but what do those mean, just as a refresher? So the independent variable is the cause. Right? It's what the scientist has. The scientist has the independence to change. Right? So the way I remember it is that during the Revolutionary War, George Washington and the founding fathers, they had the independence to break away from Britain. Right? They could choose that. Just like this artist had the independence to choose to paint George Washington on a T-Rex. Right, when you're running an experiment, the independent variable is what you get to choose to change. So in the case of, do distractions affect reaction time, you get to choose on whether to have distractions or not, right? The next variable, the dependent variable, is the effect. It's what you are measuring in your experiment. We're curious if the variable changing depends on the independent variable. All right. So when we run an experiment, we can have our question, but now we need to start to plan our investigation. How are we going to manipulate our independent variable? How are we actually going to measure our dependent variable, our reaction time in this case? So let's first start with the independent variable, the distractions, right? We're choosing to have distractions present. So what we could do in a specific experiment, and I actually used to do this with my students in class, is I would have a group of peers make an enthusiastic conversation while the subject was driving a car on their iPad, right? And so I chose to actually have that student experience that group. And then the reaction time, I measured it via the app. So there was this app that you'd be driving and then something would come up and you would have to react in enough time to hit your iPad. And that time it took, that was your reaction time. So that's specifically how I'm measuring reaction time. So now I'm starting to actually think about how I would make this investigation happen from my question. All right. So this is just I know we've gone over this before, but here's just a quick refresher in terms of, the data I'm going to be collecting for my dependent variable, what I'm measuring. So I could have qualitative data. So this just describes the quality of an object, like an apple's quality would be red or a smooth surface. I could also talk about the quality of water in a beaker. It could be a low level of water. These are more descriptions. Then I could also have quantitative data. So when you think of think of quantity or quantities in math. So these are numbers, and these are helpful because they allow for precise measurements that we could all kind of agree on or understand from group to group or from person to person. So for instance, 5 grams, 21 degrees Celsius. This would be an example of quantitative data that we could possibly get. All right. So when we run an experiment, we need to have at least 2 groups, and in general, we will say one group would be the experimental group, and the other group would be the control group. So the experimental group is the group that receives the treatment. What does that mean? Well, let's go back to our experiment on distractions affecting reaction time. And the group or a person or a group of people that would be driving with all these people talking around them with the distractions, that would be the experimental group. Right? And well, let's say that we run the experiment with the experimental group. You have these distractions and the reaction time is 0.5 seconds, a half a second. Well, did that affect the reaction time or not? Well, we don't know until we compare it to something else. Right? So that's why we have to have the control group. All right, so let's say in the control group, it's the group that doesn't receive the treatment. We don't have distractions. The person's just on their iPad and they're doing the reaction time app. All right. And let's say they do it and they have a reaction time of 0.2 seconds. So that's way faster than our experimental group. Now we could compare the 2 treatments. And we're like, wow, yeah, distractions definitely affect reaction time. In this case, it actually hurts reaction times. So it allows you to compare things. Now, one thing I'm going to say is that not in every experiment are you going to have an experimental group or a control group. As long, like specifically, sometimes you just might have groups that you need to, but at the end of the day, you need to have groups that you can compare. So this is what I mean by that is think about our jumping bean lab, right? If one of your groups may have been hot, one of your groups may have been cold, all right? As long as that was the only thing that you were manipulating, we could compare those two groups, right? Same thing a lot of times happens if you're testing males versus females in terms of how they might perform or react to certain things, right? You can't really have a control group, but you could still compare between males and females, and that's enough in terms of making a conclusion. All right. So another thing that we need in an experiment is constants. So constants are extremely, extremely important, and they allow us to know that it's only the independent variable is responsible for changing our dependent variable if that is the case. So for instance, in our experiment of do distractions affect reaction time, notice in this box right here in this example experiment, in both the experimental group and the control group, everything is the same. Those are my constants. So the way I remember it is you're constantly listing things that are the same. I'm constantly listing the same person, the same reaction time, the same location, right? Constantly talking about all these things that are similar. Now notice in red, the only thing that's different is my distractions. Right? The thing that I'm trying to manipulate, my independent variable. That way, if I see a difference between the experimental group compared to the control group, I know that it had to be the distractions because there was nothing else that could have made it happen. I've made sure to keep everything else constant. All right, so what about a hypothesis? I know you guys have made these before. So just in general, it's an educated prediction. And the template we'll use is an if-then statement. So if, and then what the independent variable is doing, then what will happen to the dependent variable. So here's a few examples of an okay hypothesis, or in this case, I labeled a bad one. If a person experiences group members talking to them, they will react poorly. Right? That is a good prediction. It's a prediction. It has the if-then statement. But the one thing is that a lot of times you need to have, and students need to have, a more specific prediction that relates to their dependent variable. So this would be a better one. It's almost the same. If a person experiences group members talking around them, then they will have a larger reaction time. So notice the only difference there is that I'm being a little bit more specific. I'm measuring reaction time, right? So I'm including that in my hypothesis. I'm not just being general and saying like, oh, they'll react poorly. All right. So the last thing about planning an investigation is making your data table. Right? This is a way that you could, once you start collecting your data, already know how you're going to organize it, and it helps you actually understand what your independent and dependent variable are going to be when you make your data table. So here, sometimes data tables could look a little scary, but at the end of the day, if we look at the left table right here, this is all they are. Right? On the left-hand column, usually you have your independent variable, and on the right hand, you have your dependent variable. Right? And then what we need to do is, since sometimes we're going to have a bunch of data, we just need to kind of break that down and organize it a little bit more. So that's what we're going to do. We're going to start with this general table, but then I'm going to go up here where I'm going to name my independent variable. In this case, it's the environment that the person's experiencing. My dependent variable is going to be my reaction time. I'm measuring it in seconds. The units are really, really important. I notice that for my environment, I don't really have units for that. So then I break it down even further. Well, what are my two different types of environment? Oh, okay, I have my experimental group, my distractions, and I have my control group, my no distractions. So, well, maybe I want to run multiple trials, right? I want to make sure that maybe if the person clicked the button really fast that, maybe it wasn't just this freak accident. I want some consistency. I want to see that they're always clicking about at the same time. So I'm going to have multiple trials. So I'm going to take my data table, right, and in the dependent variable section, right, I'm going to start to split it up a little bit more. Right? So it's still the same type of graph. I'm just going a little bit more, or a table. I'm just kind of going a little bit more specific. Where now I'm saying, okay, within the cell that kind of meets up between my reaction time and the distractions, I have trial 1, trial 2, trial 3, and then I can take the average of that. That makes my data more valid, more reliable, more precise. So this would be a good example of a data table right here. So just to kind of wrap that up, remember, in terms of a data table, we start with something really, really simple, just an independent variable column and a dependent variable column. Then you just need to think about how are you going to break that up where you could kind of start to get a bunch of data points to make sure that your experiment is robust and good enough. Right? So this is it for planning investigations. Thank you for watching the video. I'll see you guys soon.